Hello, students. This is Dr. DA again, and this is the continuation of our experiment 9A, the titration of an unknown solid acid. And what I'm going to do in this video is walk you through a sample set of calculations, and you can follow along. By the time you see this, you will have received a file with data from an unknown. And so you can choose to either just follow along what I'm doing, or you can go ahead and take out the data sheet that you received and work alongside me in doing the calculations, but with your data. So I'll leave it up to you. As usual, I go and take data from a former student of mine. So that's what I'm going to do. And we're going to show you some data from a former student, Stephen. Very bright young man. He went on to become a very, very prominent surgeon. But last I heard, he always was into, magic and the mystic stuff. And I hear that he got himself into some kind of a strange system there in New York and went to Nepal or somewhere. I don't know. Anyway, I think he's into the mystical arts or something like that. But anyway, he was a great student, and here is a sample data set. Perhaps not the same exactly as the one you're going to get, but similar. Uh, Notice one thing here that, of course, in all of our labs, we use KOH rather than NaOH. So although we use the same data sheet as the lab has, just point that out. Don't forget that you always want to make sure that if given to you, you would write the identification of your unknown. Some instructors, they don't tell you what it is. They just basically write it down on their roster, and then they check against what you were given. But in our case, you're going to be given an unknown identifier to work with. Again, remember that the modification we made was that instead of doing what the lab said, which was to weight the test tube with sample, and then the test tube after you pour the sample into the flask, we weighted the sample directly, and that's the data. Okay, there are a couple of pieces of data here that are trivial, such as what was the volume of KOH delivered and the volume of HCl. And as usual, I like to put numbers in here. So I'm going to put numbers here on the side, 1 and 2. And then down here, I'm going to skip down to 3, 4, 5, 6, 7, and 8. And the first thing I'm going to do is, I don't need to show this in my calculations if I don't want to, all right? But let's do this. Let's do it. Let's humor our audience. Remember, you always want to have an extra piece of paper where you're going to write down your calculations. And you want to do these in pencil so that if you have to fix a mistake, you can simply erase. And we're only going to show here the first trial. You don't have to display both. You'll have to do both sets of calculations, obviously, but you don't have to display both of them. So the first thing we want to do is let's find out what was the volume of KOH and the volume of HCl. So this will be item number 5. All right. This is the milliliters of KOH that we used. So according to our, numbers here, that would be item number 3, the final, minus the initial, which was 10, right? So that would be 28.35. Let me zoom out again. Okay, 28.35 minus 10.00, and that gives us 18.35 milliliters. All right. Careful with sig figs. All right. So I'm going to put that number in here, 1835. Okay. Now, for the HCl, remember that we said that if you overshoot the titration, what you can do is you can use a standardized solution of HCl and do a back titration so that you consume the excess KOH and you can resume your titration as if nothing had happened. So in Stephen's case, he had to use a little bit So the milliliters of HCl that they use, that would be item number 6 minus item number 7. In other words, 20.75 minus 20.00, and that gives you a total of 0.75 milliliters. And that's the number we're going to write down here, 0.75. Notice that I'm doing this in pencil. Of course, what might happen is that the video quality might suffer a little bit here, but don't worry, I will scan these pages and post them along with the video later on, okay? Don't worry about it. Okay, so our goal essentially is to find out in this sample of my acid, how many equivalents were there? In other words, what was the chemical power to neutralize KOH? How many units of KOH is this sample capable of neutralizing? All right. So our first thing is to find out what were the number of equivalents. And again, I'm going to substitute here. I'm going to change NA. I'm going to put K instead. All right. So let's do those calculations now. All right. Let's find out item number 10. How many equivalents of KOH did we neutralize? All right. So that's going to be item number 10. How many equivalents of KOH were neutralized? Total. All right. So according to our data, we saw that our student took 18.35 milliliters total. So we're going to put that in here, 18.35 mLs. And their solution of KOH had a molarity of 0.4685. So that's 0.4685 moles per liter. But since I want to cancel milliliters, I'm going to convert the liter to 1,000 mLs, okay? And that way I can directly cancel out the volumes. And remember, in the case of KOH, since it's only one hydroxide unit, per unit of KOH, we would say that there is one equivalent of KOH for every mole of KOH. All right, that's what we're saying. So you can pull out your calculator and figure out what that is. Careful with the sig figs again. This number has 4 sig figs. This number has 4 sig figs. So I need to write something here in sig figs that has 4. And this comes out to be 8.597 times 10 to the negative 3 equivalents of KOH. In other words, that is how many moles of KOH were actually neutralized. All right. That's how many equivalents of acid were required. So I'm going to write down over here, and 8.597 times 10 to the negative 3, okay? Since the table already has the units here, oh, you know what? I forgot to put the numbers on here. I'm sorry about that. So this was item number 9, 10, which is what we just did right now, 7, 12, 13, 14, and 15. Okay. And, you can treat this in many different ways. I could simply say, well, this is how many moles of KOH I have, because KOH, basically one equivalent represents 1 unit of KOH neutralized. So it's somewhat interchangeable at this point, okay? So please don't get confused with that. Now, here's the thing. This is the total KOH that reacted, total. But I want to find out how much was the KOH that reacted with my acid. Problem is, I had to use some HCl to back titrate, so I need to subtract those moles of KOH that are in here that actually reacted with my HCl, not with my unknown acid, okay? So I'm going to go to item number 11 here. All right, here we go. Item number 11. This is the number of equivalents of HCl. Okay, and we saw there that it took 0.75 milliliters of HCl, right? And in our trial here from Stevens day, the molarity of the HCl was 0.5105. So 0.5105 moles of HCl per liter, but we're going to use 1,000 milliliters. So we can cancel out the milliliters. And again, HCl has only one hydrogen it can transfer. And so it will mean that I'll have an equivalent of HCl for every mole of HCl. Okay, and that'll cancel out. And of course, it should cancel over here, but I forgot. All right. So I'm going to find out what that is. This number only has two sig figs, so I have to be careful in rounding my final result to two sig figs, and that'll be 3.8 times 10 to the minus 4 equivalents of HCl. I'm going to take that number and I'm going to write it down here. 3.8 times 10 to the negative 4. And this is where it's important to remember what we did. We used this HCl to neutralize excess KOH. I need to adjust the total KOH that I delivered by the amount that actually did not react with my acid, but with the HCl. So what I'm going to do here is I want to know exactly how many equivalents were present in my unknown sample. So remember, that would be the number of moles of KOH that were neutralized by my unknown acid. So I'm going to have to subtract item number 10, which is the number of KOH total minus the number that actually got consumed by the HCl. It's sometimes hard to do subtraction and additions in scientific notation, and it's hard to see where you're going to do the rounding. So I'm going to do this in decimal notation. So I'm going to write this item here in decimal notation. It'll be 0.00857, right? That's item number 10. And number 11 would be 0.00038. I'm going to subtract that, and I'm going to get 0.00817. Rules of significant figures say that when you are adding or subtracting, you have to round to the lesser number of decimal places. So I'm going to run a line through here that tells me where I need to stop, which means I can only report up to this digit here, but since the next digit is bigger than 5, this means I'm going to write this as 0.00822. All right? So when I write this over here, I'm going to go back to writing it in scientific notation form, and this would be 8.22 times 10 to the negative 3. Again, remember, of all the moles of KOH that reacted, this is the amount that was neutralized by my acid. Therefore, that is how many equivalents I have in my acid sample. So what I want to find out now is what is the equivalent weight or mass, right? You can also use the word mass here. So let's find out item number 13, our equivalent mass. So that would be the number of grams, which we had here in item number 9, grams, divided by the number of equivalents here in item number 12. So in Stephen's data, this was 1.0945 grams. And there were 8.22 times 10 to the negative 3 equivalents. You'll notice that that number there limits our precision to 3 sig figs. So you can do this calculation and find out that this is 133 grams per equivalent. Okay? So that's the number we're going to transfer down to our data sheet. So in Steve's example here, he had equivalent weight of 133 grams per equivalent. Now, I'm not showing it here because I don't know, everything kind of magically disappeared here from Stephen's data, but I do know that in his final set here for his second trial, he obtained a value that was 124 grams per equivalent. And so we need to find out what was the average and what was the percent difference between these two values. So let's go ahead and do that. This is item number 14. We're going to calculate the average. So that would be 133 plus 124 divided by 2 items. Again, don't forget that since this number represents a counting of items, it's not contributing to the significant figures here. So we have an addition here with no decimals. Whatever we get there divided by 2, that's going to be it. So without any decimals, this averages out to 129 grams per equivalent. Okay, so I'm going to write that over here, 129 grams per equivalent. And of course, your data set might be similar, might be different, but eventually you'll arrive at an average equivalent weight here, equivalent mass, all right? Okay, we always like to see how reproducible our results are. You know, what is the difference between these two items here? So we're going to calculate, therefore, now the space here. Go. We're going to calculate now what was the percent difference. So remember that the way you calculate that is you take the difference between the values. So value 1 minus value 2, absolute value of that, we're not concerned to whether it's above or below the average, divided by the average times 100%. That's what we call the percent difference. So in our case, that's going to be absolute value of 133 minus 124 divided by the average, which was 129 times 100%. Let me look at my calculator for a moment. Let's bring it on board here just to make sure we got this right. So I have 133 minus 124, and that equals 9. No decimals. So when I divide by 129, I'm carrying only 1 sig fig in here. So when I divide by 129 and I multiply that times 100, which is just a way of moving the decimal period, it also doesn't contribute to sig figs. we get 6.976 blah, blah, blah percent, but we can only round that to 1/60. So that basically means I have roughly about a 7% difference between the two values in here. So I'm going to wrap this up by writing down 7% here. Okay, these are my calculations. So when I turn in my lab report, I will have to show, of course, the pre-lab outline. My data sheet, which you will obtain, will be given to you, but you'll have to fill in the values, and your calculations sheet for at least one of the trials. If you want to show both of them, that's fine. You're only required to show one. And of course, you also have a few post-lab questions that you're going to have to answer, okay? So in our next video, I'm going to walk you through those post-lab discussion questions. I'm going to probably extend it a little beyond what the questions are, but just kind of get you on your way to being able to solve those. So thanks a lot, and I hope you enjoyed this, and best wishes with working with your data sets. And we'll see you in the next video where we talk about the post-lab discussion questions.